Okay, so these are double angle identities, so there's a couple more identities.
Do we have to remember those?
I don't know. I don't know which ones you have to know, which ones you have to memorize, and which ones you don't, but I will try and find out for you. I'll look and see if they sent us I don't think they did send us a formula sheet for this class. They did, but I'll look. And if not, I'll ask her.
I would love if they did.
And we're just like, remember everything.
That'd make it much easier.
Don't.
Where's my formula chart?
I know that there are some that they're going to have you memorize, just because that's just the nature of it. So, yeah, I mean, but there's always some that we just say, hey, you can always look it up.
Is that the title?
Yeah.
Okay.
What is it? 7-4.
Yeah.
Cosine 2 and okay, so cosine has 3 different double angle identities. It could be any of these 3. And you just use whichever one makes the most sense with the problem you have. So. All right, so those are the cosine 2-angle identities, cosine double angle identities. So it could be that, or it could be that, or that. So there's 3 of them. Then sine and tangent each only have 1. So now we're going to do similar to what we were doing yesterday. You're just going to use your identities to help you solve problems, make problems easier. I didn't put my theta in there. Cosine theta is 3/5 and sine theta is less than 0. All right, so we want to find sine 2 theta, cosine 2 theta, and tangent 2 theta. All right, so first of all, they gave us cosine of theta is 3/5, so it's positive. And they told us that sine of theta is less than 0, so sine is negative. So if cosine is positive, which of the 2 quadrants would we be in?
The first
4 and
and
1.
Yeah, first and fourth, right? And sine is negative, so what quadrant are we in?
4.
4. So we know that we're in quadrant 4. That's why they gave us that little information. So I'm just going to write that down so that I don't forget to double check my signs on everything. Okay. So first I'm going to find, because I already have cosine theta, I'm going to go ahead and find cosine 2 theta. I think that's the easiest one to do first. Maybe not, but I'm going to do it first. And I'm going to use, because the only piece that I actually know is cosine, I can use this one to find cosine 2 theta, because it only has cosine in it. So I'm going to use the middle one, 2 cosine squared A minus 1. So cosine 2 theta is going to equal 2 cosine squared theta minus 1. And I know what cosine theta is, so I substitute that in. So 2 times 3/5 squared minus 1. And now it's just algebra. So I have to, order of operations, you have to square first. It's going to be 2 times 9/25 minus 1, which is going to be 18/25 minus 1. That's 18 25ths minus 25 25ths, which makes this cosine of 2 theta is going to be negative 7 25ths. Get it? Not bad, right? See, that's not bad.
Actually good for.
Yeah. See?
That was
Easy.
easy.
All right. Since we know cosine and we're looking for sine 2 theta, I am going to use this one. Oh, since I already found cosine 2 theta, I'm going to use this one and find sine theta. Okay? Y'all okay? If I use that bottom one? So, yeah, maybe. I don't know. We'll see. Okay, so cosine 2 theta equals 1 minus 2 sine squared theta. And I know what cosine 2 theta is. I just found it. It's negative 7 25ths. So I'm going to replace cosine 2 theta with negative 7 25ths. And now I'm solving for sine. Y'all okay? Okay, so I'm going to subtract 1 from both sides. And to make it easy on myself with a common denominator, I'll call that 25 over 25. That's going to make that negative 32 over 25 equals negative 2 sine squared theta. Divide by negative 2 to get rid of the negative 2. That's the same thing as multiplying by negative 1/2. My negatives become positive. Negative times a negative is positive. 2 goes into 32 16 times. So I get 16 over 25. Oh, isn't that nice? Because they're both perfect squares. Take square root of both sides. And you get that sine theta is 4/5, positive 4/5. Now, I need 2 sine theta. So I use my double angle identity. So that'd be sine 2 theta is going to equal 2 times sine theta cosine theta. And I know both of those. So sine theta was 4/5. Cosine theta was 3/5. Multiply across, and you get 24. Oh, this? Yeah, 24 25ths. So sine 2 theta is 24 25ths.
One question.
Yes, ma'am.
On this one, since that you just add that value, do you have to do anything to this one?
Nope. And the last thing I need is tangent 2 theta. Well, if you know sine and you know cosine, you also know tangent, because tangent is sine over cosine, right? So we can use that. So tangent of theta equals sine theta over cosine theta. So in this case, we know sine is 4/5, cosine is 3/5. Keep, switch, flip, and you get tangent is 4/3. So that's tangent of theta. I need tangent double theta, tangent 2 theta. I'm going to use my tangent identity. So,
Wait, another tangent identity that we have. Oh, never mind.
so tangent 2 theta is going to equal 2 tangent theta over 1 minus tangent squared theta. So it's going to equal 2 times 4/3 over 1 minus 4/3 squared. So that's 8/3 over 1 minus 16/9. 8/3 over 9/9 minus 16/9. That would be 2/7 keep, switch, flip. You got 24/7. So tangent to theta is 24/7.
I'm never gonna find a more uniform way to write this process.
Yeah. Yeah. It's just kind of all over the
It's
place.
move everywhere.
Yeah.
Like, first semester, I used 2 of these.
I was gonna say that, but you have to
But you have to be
okay with using a lot of paper and just writing down the page, so you don't lose yourself. You know what I'm saying?
Everywhere. Because then I'm like, oh, I lost so much space on the
Or-
other side.
You just write wherever you want, and then you can look at your notes again, and you just remember how to do it.
I don't know.
Yeah,
If
that
that's a
would
good
work.
idea, but
That's something.
you can go for that if you want to. You know.
Yeah, I tried that, and that didn't
It's
work.
worked decently so far.
Yeah.
Okay.
Occasionally I have to look back, but it's alright. And whenever I do have to look back, I just confuse myself.
How would I add this one? Because I'm like, with you, I just do like
Normally I
A3.
just do it in
Uh-huh.
my head,
And then do it
I'm
top.
Uh-huh.
looking back at it like, how do I do it?
Then just times 4D.
Mhm.
Multiply. So it'll be 4. Like that?
Yeah. Oh, sorry. This is cosine. 2 theta equals 4/5.
Maybe if I use front and back, I'll feel it. Maybe if I use like front and back.
Oh, you don't use front and back?
No.
That wastes so much paper though.
No,
Yeah.
I don't use like front and back, like I never
I don't-
use it for
I don't
anything,
either.
just because it bothers me that I can like
That you can see through it? Me
Yeah,
too.
yeah,
I don't ever
do
use it either.
these two together
And just
in my
write them
phone.
No,
You can't, because one has a
No.
one doesn't.
I like writing with pen over.
Just write
Yeah.
lighter.
Oh, she already wrote it down.
Okay, so cosine 2 theta is 4/5. I want to find all 6 trig ratios of
Trig.
theta, not double theta, but just theta. So I'm going to use my cosine double angle identities. The first one I'm going to use is the one that just has cosine in it because that's all they gave me. So cosine 2 theta equals 2 cosine squared theta minus 1. Okay, so since they gave me cosine of 2 theta is 4/5, that's the left side. So 4/5 equals 2 cosine squared theta minus 1, and now you're just solving for theta. So I'm going to add 1, so it's just algebra. Remember, 1 is the same thing as 5/5. That way I have a common denominator.
Yeah.
So that's 9/5 equals 2 cosine squared theta. I need to divide by 2, which is the same thing as multiplying by half. And that gives me 9/10 equals cosine squared theta. Take the square root. Now 9 is a perfect square, so that gives me 3/square root 10, which you do have to rationalize. Multiply both the top and the bottom by square root 10. And you get 3 square root 10 over 10 equals cosine theta.
Is that how
I'm
that would
actually
look if I
following, so
was
let's
doing
figure it
that?
Uh-huh.
So I would just multiply it by that and do whatever I did that and do those.
And we gotta do that for all of them?
So, well, no, because once you know cosine, then once you know cosine and sine, you know all the others, right?
Yeah, because there's only
Because
one.
but you know them all anyway because you
Yeah.
flip and
Yeah,
then
yeah.
tangent is just sine over cosine. So, okay, so we just have to find sine really, which I'm going to use the double angle identity, which is, the cosine identity that has sine in it to find sine. So that one's this one. Cosine 2 theta equals 1 minus 2 sine squared theta. And that would be 4/5 equals 1 minus.
And this is to find sine.
Yeah, this is to find sine.
subtract, so I have 12 r squared minus 8r, can I subtract that, or just because that one does, or it just stays?
Yep. All right, I'm dividing by -2, which is the same thing as multiplying by -1/2, which means my negative becomes positive, and sine is 1/10, or sine squared.
So, is -8 plus 1 really -7, or really,
I remember that so good when it was
Mine,
on
it just says
page.
like
Plus 1 is -7.
so it's -8r plus r?
R plus R is -7.
Being-
Okay, I had to rationalize, and so I ended up getting square root 10 over 10 is sine theta. Y'all good?
Yep.
All right, so tangent is just sine over cosine. So keep, switch, flip. So tangent is 1/3.
Wait, where'd you write
Where'd I do what?
that?
So remember, tangent of theta is sine over cosine. So I put sine over cosine. That's a big division problem. So instead of dividing a fraction, I keep switch flip.
Oh, you can cancel
Tens
out?
cancel, square roots cancel, yeah.
Just if you flip something.
And so I'm left with just a 3 on bottom, which is 1/3.
Wait,
I
I'm
didn't know
gonna
you
have to
could
write
cancel
that out.
those.
Did you write that out? Wait.
That's not too bad.
And those cancel,
All right, so secant is just cosine flipped over. And if you'll just take the one that before you rationalized it,
Oh, wait, we gotta still keep
it's
up.
just square root 10 over 3. Cosecant is sine flipped over, so I'll just take the one before I rationalized it. So it's square root 10 over 1, or just square root 10. And cotangent is tangent flipped over, so it's just 3.
Is this a long unit? I mean, it's got 2 separate assignments.
The last one was 3.
Yeah, it does
Or
have 2 separate.
I think the reason it has 2 separate assignments is because they took the middle chunk out.
Oh.
So I think they
that's
split it up.
Okay.
Yeah.
How many questions did you total? Do you know? Alright, good talk.
I know there's, sorry. I know there's 18 on the first part.
I'm hoping there's like another 4.
Let me tell you, this spring is like the worst time of the year for me.
It's the worst for everybody because there's a billion things going on.
Because
Yeah,
it's not,
exactly.
because in the fall it's just like football and volleyball
Simple
ish.
things.
And then in the spring it goes track, soccer, basketball,
Softball.
softball, baseball.
It's not even sports for
New
me, it's like
classes.
that's region conference
You're
season,
doing
that's
half
state
credits.
conference season, that's cheers, like cheer season is starting. We have to figure out the themes for pep rallies next year. We have to do like do tryouts and everything.
Is this one a long one?
And then I took more credit
Not
this
as long.
semester than last semester,
Flip the page.
which was
I can't spell. Oh well.
It'd just be like that.
I put simply. Are you recording this?
I am, because we have a lot of people not here. So.
I didn't see the time on the clock, right?
Okay, so I need my page that I wrote all the identities on.
It's 7. I think that's 7.
Okay, so if you look at the double angle identities that I wrote, look at this one. Cosine squared A minus sine squared A. That looks, remarkably like this, right? So what that means is that I could rewrite this, instead of it being cosine squared 7x minus sine squared 7x, I could just rewrite it as cosine Now, if this was A, I might make sure I'm making sense.
7x altogether.
If this is A, and this would equal 2A, right? Then I can put cosine 2 7x. Does that make
Where's
sense?
the 2 come? Isn't the 2?
But the two is in the identity.
Because it looks like
Ah, okay, okay.
Are we not gonna change that to like 14x?
basically it was
Yeah, we are.
equal to
Okay.
7.
I just want to make sure that you know what I did.
Oh, okay.
Because I was like, I saw the 2 up there and I was like, well, that's
That's
word in
new.
exponent, not in the,
So,
there's a difference.
so there you go.
Okay.
That was
Okay.
the answer?
Yeah.
Oh, yeah,
I actually knew what to do on that one before
yeah.
you said
Same.
it. I was like, you're joking?
I was making sure it was.
Yours, aren't you cool? I didn't realize. I was clueless.
I did not mean to make that 15 long. Okay, so I got cosine 15 degrees and sine 15 degrees, cosine 15 degrees. Now, remember what we're in. We're in the chapter on double angle identities. We're in the section on double angle identities. What does that look like, kind of? Which one does that kind of look like?
1 second, let me finish writing it down.
Sine 2a.
Yeah. So I'm going to write out the sine 2a identity. The sine 2a identity is sine 2a equals sine a cosine a. Oh, 2, sorry, there's a 2 in front.
2a.
Okay, so let's say that this is a again. 15 is a. So I could write this as 2, I'm going to different color. I could write this as sine 2 15 equals 2 sine 15 cosine 15. Are we good so far?
So you just plug it in.
Yeah, I just plugged in 15. I just said, I'm just going to call 15a. Now, here's the problem. This pink part almost looks like the yellow piece, but not quite. Why?
Because we need to divide the 2.
Yes, because we have a 2 in front. We need to get rid of that 2. And so you're exactly right. We're going to divide by 2, but the way they would rather you write it so that everything's not looking like it's divided by 2 is to write it as 1/2 times 2 sine 15 cosine 15.
Why?
Because then it would be like dividing
Because that's-
the-
1/2 of 2, that cancels, and you're left with sine 15 cosine 15, right?
But they don't want us to say divided by 2 because then that would change
Right.
the numbers.
Are we supposed to be like?
So that means you're supposed to do the other side as well, then, right?
Mm-hmm. Okay, and so since those two things are equal, this becomes 1/2 of sine 30 equals sine 15 cosine 15, which is exactly what we wanted it to equal, and that I can figure out because 30 is on the unit circle. Sine of 30,
Oh, it's 3/2. No, 1/2.
the half. So 1/2 times 1/2, that's a fourth, which means sine 15 cosine 15 equals 1/4. That was a little harder, but it just takes a little, you have to look at it a little bit. You get it. Okay, are y'all okay? Now look, the next one, make sure you understand it.
Uh-oh.
Stop me if you don't, because the next one, I promise you, it will show up again. If it doesn't show up like this, it'll show up real similar.
Won't show up, I drop the
So-
class.
No, that's true.
Could you do more of what you usually do to when like you ask us questions? I like to do.
Okay.
What? I had heard
write sine 3x in terms of sine x. All right, so the very first thing you're going to do, and this will be the same if it says write sine 4x in terms of sine x, or write sine 6x in terms of sine x. The first thing you're going to do is break that up into addition so that you could use sine addition property. So I'm going to, instead of writing it as sine 3x, I'm going to write it as sine 2x plus x. Or x plus 2x, doesn't matter what you come first. Because 2x plus x equals 3x, right? Now, the reason that you want to use a 2, though, so if this said write sine 4x, you would write it as 2x and 2x, not 3x and 1. Because we don't have a triple angle identity, but we do have a double angle identity. So I can use my double angle identity to change stuff. So I want to try to get it in terms of either double angles or single angles, because that's all I know. That's not all I know, but it's most of what I know. All right, so now what I'm going to do is use my sine addition identity.
Isn't that sine A cosine B plus sine B cosine A?
Yep.
Yeah.
So sine A cosine B plus sine B cosine A. Yep, go ahead.
Always do that.
Yeah, in my labs it wants us to put it backwards. It's weird.
Oh, it doesn't matter. It's because it doesn't matter. A multiplication can be done in any order, so it doesn't really matter what order you put it in. Okay, so now I'm going to use my sine double angle identity. So instead of sine 2a, I'm going to replace this piece right here with 2 sine x cosine x.
Oh, you just made a formula out of
And then there's already a cosine x there. You all okay? You know where I got that?
Oh, yes.
Okay, so
Are we
Where
going to
did
be
I put
doing
my-
that on the other one?
oh, down here. Okay, so remember, these are my double angle identities. And sine 2a or 2x equals 2 sine a cosine a. So that's all I did, was just replace. This is equal to that. So I just took it out and replaced it. I'm going to do the same thing on this part with my cosine double angle.
Okay. Which one are we going to put?
That's a really good question. It really doesn't matter. You can use either. I would use it really doesn't matter, honestly. I'm going to use cosine squared a minus sine squared a. Just because. So the sine x is already there. I'm not changing anything about it. But this cosine 2x, I'm going to replace with cosine squared x minus sine squared x. Okay, so now I'm just going to do a little bit of simplifying. Okay, so this left piece, I've got 2 cosines right next to each other. So instead of writing cosine x, I'm going to write cosine squared. So I'm going to write 2 sine x cosine squared x. And I'm going to distribute this. And write that as sine x cosine squared x minus sine cubed x.
Why the cube?
Because sine times sine squared.
Because there's x times
Because there's
x squared.
1 here and there's 2 there already, so 1 times 2 more is 3.
1 times 2 is 3.
Well,
It's just
when you're
we
multiplying
have x
exponents-
squared times x.
when you're multiplying exponents, you add. Okay. So I can. Let me think what would be the easiest thing to do. These 2 things are technically like terms. so I can combine them. There's 2 sine x cosine squared x's, and there's a 1. This then that has a 1 there. So that means I actually have 3 of those. So 3 sine x cosine squared x minus sine cubed x. I am now going to factor out a sign, because these both have a sign in them. It's the GCF between the two. So that would leave me,
Oh, because since they're subtracted from each other, we don't take it out because
right,
it's like 2 terms.
yeah, it's 2 separate terms because of subtraction. So I'm going to take out a sine x. That's going to leave me 3 cosine squared x minus sine squared x.
Wait, how is it 3 sin x?
It's 3 cosine.
How is it? Because there were 2 of them. There's 2 right here, and there's 1, and so I added them together. It's the coefficient.
Those are, okay, I see,
Yeah,
those are
okay.
exactly the same.
Yeah.
Yeah.
Like,
I see.
And now I have cosine squared x.
Oh, can't we break
Minus.
this down to other formulas? Or do we not?
No,
use it?
please don't.
Well,
We need to write sine 3x in terms of sine x.
they didn't tell me, like, they didn't give me where I was going, and all they told me that I just needed to write it in terms of sine x. So I just need to get rid of my cosine.
No, we can't.
Oh, which I can do, because this sine, so that's this, cosine squared a minus sine squared a.
Mhm.
Yeah.
So I'm just going to replace it with this.
Is that the whole point of this, just getting rid of cosine?
Uh-huh. Well, it was to get rid of 3x. But it says in terms of sine x. So that means I can't have any other things in there but sine.
So we basically just, like, we
took
have
everything.
that formula, we get to take it out.
Yep.
All together, it's just done.
Yeah, I can just take this part out and replace it with what it says it's equal to, which is 1 minus 2 sine squared x. So that gives me sine x 3 times 1 minus 2 sine squared x, which I'll distribute to 3. So that's sine x and then 3 minus 6 sine squared x. And that's it. And to be honest, you could redistribute the sign since it could be 3 sine x minus 6 sine squared x, or you don't have to. I don't know how my loves once you put them. Either way, it's the same thing.
Perfect.
For us, no problem. Yeah, no, I'm definitely telling this, so I'll be surprised if we get 2 right.
It's just a lot to remember.
It's a lot of formulas.
Exactly.
If we have a formula chart for this class,
I will look and see what they say. I'll go look in just a
Or
minute.
can we
Because
just
then I
have
feel
a
like-
flashcard?
I feel like this is in the sense of understanding
No, I'm gonna start
my
using
best
big
students
stuff, you know,
on.
Oh,
They
yeah.
don't give us formula, try to use one.
Okay, so the next one is a word problem, and this is the last one of this half, and then the other half we'll do, I don't know. There's a lot of people out tomorrow, so I hesitate to do it tomorrow.
So if you're like, we gave you calculators,
There's
we
a lot
won't
of
give you
people out
formula
tomorrow,
charts.
too.
Yeah, tomorrow's like, I don't remember.
Track day.
Track
Yep.
and something else. Track and something else.
Well, I knew today was gonna be a big
Oh,
day.
and the visit to Weatherford College, and there's another thing, a bunch of things tomorrow. I've signed so many pages.
I was actually gonna have you sign mine, but then I forgot, and I realized that was the last day.
Okay. Let's see, what am I doing?
But one.
So I'm here.
Would it be good?
Hey, at least you
Okay.
don't have to sign papers for every time I meet.
I mean,
It's one
really,
less signature.
it's funny that we do it at all, because I don't really think it means anything,
Doesn't matter.
but whatever.
I can't wait to graduate, never have to do this.
Math?
Never again. I want this style at least. Maybe some like simple adding or something. Maybe some
It gets
multiplication.
even more harder than this. Combination of trees.
Never touch trigonometry again.
Oh, come on, it's not that bad. Not yet.
Yeah, you're doing this.
You know what? We can't really do this one
Yay.
without a calculator.
Oh, well, we,
So
Yeah.
without a graphing calculator.
Oh, okay.
I was like, what?
You're like, wait a minute, we have a calculator.
Yeah, I was like, oh, wait.
So we're gonna stop there because this we're to the section that we get to leave out, and then either tomorrow or the next day we'll look and see how many people are here. We'll do the last half of the chapter. So I'll be honest, I'm not sure if they split the two assignments evenly or not. So you might get to problems that you don't know how to do yet because I don't know where they split the problems up. So if you do, don't worry about it. It just means we're gonna get to it tomorrow or the next day.